Thank you for watching, and thank you for doing this. We are going to get more complicated now, but we're taking one step at a time. Remember, we did factoring. Now we're going to do something which is to sort of mumbo jumbo up things before we can even get it to the point where we factor it. The format we need to get it into factor or make it simpler is this: ax squared plus bx plus c equals 0, where a, b, and c are coefficients like 2, 3, 5. Now, what if you get something like this? It's all mixed up. What do? Well, we just start solving it. We start doing stuff. Oh, x plus 2 times x plus 2. Why? Because it says x plus 2 squared. Whatever it does, it tells you basically to take whatever's in there and multiply it by itself. And then we just rewrite this side. It's always important to keep writing. What do we do now? Well, let's expand it out. We're going to FOIL it out. Okay, x squared plus 2x plus 2x, right? Plus 4 equals minus x minus 2. We've laid it all out. We're going to start collecting like terms. We've got x squared plus 4x. When we add that and that together, plus 4 equals, writing it down again. Do not be lazy. Write everything down. What do we do now? We add x on both sides. So let's do that. X squared plus 5x. You see, I'm not skipping steps. I'm not trying to do too much in my head. I'm not multitasking. Guess what, guys? This is old school math, and it works. So do it this way. Plus 6 equals 0. And that's what we want. We want everything on the left to be in the form ax squared plus bx plus c. And we want everything on the right to be equal to 0. Why? Because then when we factor this, and we can, the factors of 6 are 6 and 1 and 3 and 2. 3 and 2 add to be 5. We want to get a plus 3 and a plus 2. Okay, so 6 and 1 plus 3 and plus 2 are the ones that are going to work best. So we got x plus 3 and x plus 2, and we're good. So let's FOIL it out and we'll see. X squared plus 3x plus 2x and plus 6. We're done, we're good, it's going to work. And now, what do we do to finalize this answer? Well, what have we done? Well, we've actually found solutions for x we don't know we have, but we have. This is the thing that a lot of people don't quite understand. So let's think about this a little bit. All right, focus in on me for a moment. All right, so what we've got now are potential solutions for the problem we started with. Because this problem has an equal sign in it, it's not just an expression, it implies that we are going to solve for x. So be clear, when we have an equal sign, we're going to solve for something, and when we don't, we're going to simplify but not solve. So be aware of that. That happens all the way through algebra. You have to recognize when you're simplifying and when you're solving. Equal sign is the key to know. When it's there, you're solving. So check it out. X plus 3 and x plus 2 equals 0. Well, think about it. What does it take to make this equal to 0? Why do we even need to make it to be 0? Well, let's just take an example. 5 times what number equals 0? What do we need to have for x for that to be 0? Everybody knows that if x were equal to 0, we'd be in business. It's the same thing here. X plus 3 and x plus 2, this is just an example, so I'm going to erase it. But if I have x plus 3, I'm going to move it up here, x plus 3 and x plus 2 on equal to 0, it means that one of these two has to be 0. So x plus 3 equals 0 actually means that x has to be equal to negative 3. Check it out. If x is negative 3, that's 0. This whole thing's 0. 0 times anything is 0. That's true. It's good. That means x equals negative 3 is a solution. We can also have this, x plus 2 equal to 0, and x equal to negative 2. So we have two potential solutions. Two things make this true. If this were negative 2, that's 0. 0 times anything is 0. And we're in business again. So the two solutions are negative 3 and negative 2 to this problem. It started looking pretty crazy, but now we have two solutions. Boom, there you go. You get all kinds of cases in math and quadratics. And this case is a situation where it's not so easy to factor. We look at this and we subtract 10, and then the factors of 10 don't add to be 8. We can't factor, we get stuck. I'll show you what I mean. X squared plus 8x minus 10. So if you get this situation and you try to factor this, factors of 10 and 1, 5 and 2, there are no other factors. If you try to factor this and it doesn't work, like 5 and 2 doesn't add to be the middle term, so we can't factor it. 10 and 1 doesn't add. If you get to that situation, you can use something called completing the square. So that's what we're going to do here. This is an interesting technique that you have to practice to master. So keep this on one side the way it is. and then have the other number on the other side. Why do we keep this? Because what we're going to do is complete the square, literally. Remember the trinomial square where we took half the middle term and then squared it? That's what we're going to do here. We're going to take 1/2 of 8, the middle term, which is equal to 4, and then we're going to square it, which is equal to 16, and then we're going to add it to both sides. So completing the square is exactly take step 1, okay? Step 1, take 1/2, okay, which is equal to 4, and square it. So 4 squared equals 16. So now, number 2, add it to both sides. Add to both sides. And that's our second step. And we end up with x squared plus 8x plus 16 equals 10 plus 16. It's going to be 26. Notice that we've created a trinomial square. We've actually fabricated a trinomial square. This we recognize as being x plus 4 squared equals 26. And what doesn't look like we've done anything at all that's going to help, but we have. If you remember radicals, what we can do here to solve for x is take the radical of both sides. So we're going to solve this. The third step is really to factor. Okay, so we're using trinomial squares. Solve for x. Okay, by taking the radical of both sides. So we take the radical of this side, the radical of that side, and we end up with x plus 4, because the square root of something squared neutralizes it to be whatever's inside. That's equal to the square root of 26. We're going to subtract 4 on both sides. We end up with x equals, this is a plus or minus root 26, so it's going to be -4 plus or minus square root 26. And that's our answer. We literally have 2 roots, -4 plus root 26 and -4 minus root 26. And those are 2 numbers. They don't look like numbers because of the radical sign, but actually if you take your calculator and you take the square root of 26, it's equal to, something. In fact, it will be close to, It's root of 16 is equal to 4, the root of 25 is 5. So it's a little more than 5. It's root of 25 is 5, so this is probably 5.001 or something. So we end up with something like 1.001 and a bigger number here, so minus 5.001, something like that. That's kind of giving you an idea of what that looks like. So that's completed the square, guys. Again, recap, take half of the middle term, square it, add it to both sides. Then we're going to take the left-hand side, which we've kind of fabricated to be a perfect trinomial square, and we factor it out, and then we take the square root of both sides and solve for x.